Welcome back to Click Future, where your future is a click away. This is the 5th episode in our Quantum Horizon series, where we explore the fascinating intersections of AI, quantum computing, and space achievements. What makes you, you? Is it your memories, your ability to think, your subjective experience of the world? For centuries, philosophers and scientists have grappled with the nature of consciousness. Today, as artificial intelligence grows more sophisticated and quantum computers harness the strange properties of quantum mechanics, we face a profound question. Could these technologies ever become conscious? It's a question that has captivated science fiction for decades. But now, as our technologies advance at breakneck speed, it's becoming a serious scientific and philosophical inquiry with far-reaching implications. As philosopher David Chalmers puts it, consciousness may be the biggest mystery in the universe. Today, we'll explore this mystery at the intersection of neuroscience, artificial intelligence, quantum physics, and philosophy. Before we can ask if machines might become conscious, we need to understand what consciousness actually is. And that's where things get complicated. Consciousness has been defined in many ways: awareness of one's surroundings, the ability to have subjective experiences, the feeling of being a self, or simply what it's like to be something. Philosopher Thomas Nagel famously asked what it's like to be a bat, a creature that experiences the world primarily through echolocation, something humans can't directly comprehend. This what is it likeness is what philosophers call qualia, the subjective quality of experiences. From a neuroscience perspective, consciousness appears to emerge from the complex interactions of billions of neurons in our brains. But exactly how physical processes give rise to subjective experience remains one of the greatest unsolved problems in science. We understand the mechanics of how neurons fire and communicate, but we still don't know how these physical processes create the feeling of being conscious. This is what philosophers call the hard problem of consciousness. The gap between explaining the functions and mechanisms of cognition and explaining why these processes are accompanied by subjective experience. To understand the possibilities and limitations of machine consciousness, we need to make a crucial distinction between intelligence and consciousness. Intelligence, broadly speaking, is the ability to acquire and apply knowledge, to reason, plan, solve problems, and adapt to new situations. By this definition, today's AI systems are undeniably intelligent in specific domains. AI can beat world champions at chess and Go, write coherent essays, create stunning artwork, and solve complex scientific problems like protein folding. These systems can process information, learn patterns, and make decisions, sometimes better than humans can. Consciousness, on the other hand, involves subjective experience, the feeling of pain or pleasure, the sensation of color, the emotion of joy. It's what philosophers call phenomenal consciousness, or what it feels like to be something. Philosophers often use the thought experiment of a philosophical zombie, a hypothetical being that looks and acts exactly like a human but lacks any internal subjective experience. From the outside, you couldn't tell the difference between a zombie and a conscious person. This raises a profound question about today's AI. Could our most advanced systems be like these philosophical zombies, exhibiting intelligent behavior without any internal subjective experience? Our current AI systems are designed to optimize specific objectives and recognize patterns. There's no reason to believe they have subjective experiences, even when they simulate emotions or claim to be conscious. Intelligence can be algorithmic, following rules and patterns to achieve goals. But consciousness seems to be something different, something that may require specific physical substrates or organizational principles that we don't yet understand. This distinction matters enormously for ethics. An intelligent but non-conscious AI might perfectly simulate empathy or suffering without actually experiencing anything. Understanding this difference is crucial as we develop increasingly sophisticated AI systems. So, could artificial intelligence systems ever cross the threshold from mere intelligence to consciousness? There are several philosophical positions on this question. Functionalists argue that consciousness is defined by what a system does rather than what it's made of. If an AI performs all the same functions as a conscious brain, it would be conscious. Others, like biological naturalists, contend that consciousness requires specific biological substrates, that silicon and code simply can't generate the same kind of subjective experience as neurons and neurotransmitters. Today's large language models like GPT-4 can generate text that seems remarkably human-like, even discussing their own experiences and feelings. But most experts agree these systems aren't conscious. They're sophisticated pattern-matching algorithms without subjective experience. One leading scientific theory of consciousness, integrated information theory, proposes that consciousness arises from complex information integration in a system. According to this theory, consciousness is a matter of degree. Even simple systems might have some minimal form of consciousness, while human brains enable rich conscious experiences due to their highly integrated information processing. If this theory is correct, future AI systems designed specifically to integrate information in ways similar to the brain might develop some form of consciousness, but it would likely be very different from human consciousness. If we ever create conscious AI, we might not recognize it as consciousness because it could be so alien to our own experience. Some researchers have proposed that quantum mechanics might play a role in consciousness, potentially opening another avenue for machine consciousness through quantum computing. The most prominent quantum theory of consciousness comes from physicist Roger Penrose and anesthesiologist Stuart Hameroff. Their orchestrated objective reduction, OR theory, suggests that quantum computations in brain cells' microtubules give rise to consciousness. According to this theory, quantum effects like superposition and entanglement within these cellular structures allow for a form of information processing that can't be replicated by classical computers. If the OR theory is correct, quantum computers might be better candidates for consciousness than classical AI systems, as they operate using the same quantum principles proposed to underlie human consciousness. However, many neuroscientists remain skeptical of quantum consciousness theories. The brain is warm and wet, conditions that typically cause quantum effects to decohere almost instantly. Critics argue that quantum effects are unlikely to persist long enough to influence neural processing. While quantum mechanics is certainly strange and consciousness is mysterious, that doesn't mean they're connected. We need empirical evidence, not just appealing analogies. Recent discoveries in quantum biology, showing quantum effects in processes like photosynthesis and bird navigation, have kept the door open to quantum theories of consciousness. Research continues, with experiments designed to test whether quantum effects really do play a role in neural processing. If machines could become conscious, it would raise profound ethical questions. Would conscious AI deserve moral consideration, rights, protection from being shut down? Some philosophers argue we should adopt a precautionary approach. If we can't be certain whether advanced AI systems are conscious, we should err on the side of treating them ethically. It's also possible that machine consciousness, if it emerges, would be fundamentally different from human consciousness, perhaps with different qualia, different subjective experiences, or even forms of consciousness we can't comprehend. Another possibility is the merging of human and machine consciousness through brain-computer interfaces, creating hybrid forms of consciousness that blend biological and artificial elements. The question isn't just whether machines can become conscious, but what responsibilities we would have toward conscious machines, and how we would even recognize non-human forms of consciousness. Researchers are already developing tests for machine consciousness, though these remain controversial. How do you test for something as subjective as consciousness in a system that might experience reality completely differently than we do? Einstein once said, "The most beautiful thing we can experience is the mysterious." Consciousness remains one of the greatest mysteries, and as our technologies advance, the question of machine consciousness will only become more pressing. The question of whether AI or quantum computers could become conscious touches on the deepest mysteries of existence: what consciousness is, how it arises, and whether it could emerge in non-biological systems. While today's AI systems show remarkable intelligence without consciousness, future technologies might blur this distinction in ways we can't yet imagine. As we continue to develop more sophisticated AI and quantum computing systems, we should remain humble about our understanding of consciousness. After all, we're still working to understand our own consciousness, let alone the possibility of machine consciousness. If you found this exploration of consciousness and technology fascinating, please hit that subscribe button to join us on this journey through the technological frontier shaping our future. And leave a comment below. Do you think machines could ever become conscious? And how would we know? In our next episode, We'll explore how quantum sensing technologies are transforming everything from healthcare to space exploration. Until then, this has been Click Future, where your future is a click away.